Free fall motion. So what does free mean? Does it mean it doesn't cost any money? Well, it's the opposite. If you want to go skydiving, it's very expensive. Free fall means free from air resistance, free from wind. So it's just purely falling due to gravity. That's what we call free fall. So we are going to introduce the definition of free fall. And also we're going to introduce the motion description and then look at examples. Free fall motion is a motion with constant acceleration. So that being said, we can use all the equations for motion with constant acceleration. And free means neglect air resistance and wind when this object is falling entirely due to gravity. So the motion is along the vertical direction and the acceleration is the 9.8 meters per second gravitational acceleration. So this A is the gravitational acceleration near Earth's surface. Earth's surface by definition strictly means sea level. So this applies when the falling is not far from the sea level. Although it's called free falling, right? If we throw an object straight up, it's also called free fall because that's a motion with constant acceleration entirely at the acceleration of gravitation. Or if we throw a atom straight up and then it falls down here. I'm actually using this arrow that looks like an arc, but just to illustrate it's up and down, it actually means straight up and straight down. Here, this is also a free fall motion. So this is schematic diagram. And what about straight down? For example, object falls straight down. That's of course is called free fall motion. So in summary, free fall motion just means when the acceleration is the gravitational acceleration during that case. The motion, whether it's going up and down or straight down, they're all called free falls. So that's straight down. We use this ruler to measure the displacement. So next thing, free fall motion. How do we describe a free fall motion? So first we have a frame of reference we call a coordinate system. So that's for us to keep track of a motion. So this object start to move up, then move down. So the initial velocity is, initial position is y of I, final position is y of f. The object actually seems to move up and down, back down here, but this is the final position, does not have to do with the path or the exact trajectory. Displacement is final position minus initial position. In this case, it's negative because the overall, the displacement point downwards. The highest point of the motion is when velocity equals to 0. That's when it keeps going. Velocity keeps positive, positive, positive until it turns around, becomes negative. In between that point is what we call the highest point. Highest point has a vertical velocity of 0. So these are the characteristics of a free fall motion like this. That's the highest point. Another example here, let's say, take a look at skydiving. So this is a particular skydiving in front of Mount Everest. Question, what is the velocity at the end of 1 minute? First of all, we are going to assume this is not that far from the Earth. Then you'll say, wait, Mount Everest, that's very tall. But let's just keep things simple. Let's assume acceleration is 9.8. It actually may be slightly different than this number. Initial velocity, let's take it as 0. It's a falling, so it's start from rest. And it's just a free fall motion. So apply the free fall motion equations. Final velocity equals to initial velocity plus acceleration times time. Do you see here is negative 9.8? It's very important that if we're in a coordinate system pointing up as positive, then the free fall acceleration has to be negative. So in this case, it's extremely important that you get the sign correctly. So the final velocity is 588 meters per second. If we take a look at this number, is this larger or smaller than a fast car? Remember, residential speed limit is 11.17 meters per second. This is way higher than that. So this velocity is very, very high. This is moving very fast. So in summary, this is an example of a free fall motion. So we used the equation for motion with constant acceleration to solve this. The only thing that stands out here is the gravitational acceleration is negative 9.8 meters per second square. There's a common mistake. People would think the end velocity of free fall is 0. Actually, it's never 0. If you go back, the end velocity at 1 minute is 588 meters per second. So free fall motion always hit the ground with a very high velocity or with at least a velocity. Why would people think the final velocity is 0? Actually, that's really two process. Object falls from rest until right before hitting the ground. It's moving at a certain velocity. And as soon as it starts to hit the ground, there's a collision process. So the collision will change the velocity from that value right when it hits the ground to 0 when it completely stops. That's a collision. Collision is a very short period of motion in a very short period of time. So the final velocity of a free fall itself, it's never 0, never free fall. So please distinguish what's a free fall and what's a free fall plus a collision. Let's look at another example. If a lacrosse ball is thrown directly up 2 meters per second, what's the position of the ball in 0.2 seconds? Neglect air resistance and wind, I say. First, we analyze this. Read, and read. Meters per second represent velocity. After reading it 3 times, I call it initial velocity. Okay, the duration of the time is 0.2 seconds. Well, seconds can only be time. Then we try to figure out what's the position. Okay, so here I'm reframing the question. We don't have equation for position, right? But we do have equations for displacement. So I'm gonna reframe this and ask what's the displacement? Based on the known quantities and the unknown quantities, what I did not write here is acceleration equals to negative 9.8. Okay, so 3 known quantities and 1 unknown. The one equation that connects with them, let's look at this. Oh no, it does not connect all of them because we don't have a final velocity, so this equation won't be useful. All right, so try another one. Do not give up. Try another one here. Displacement is initial velocity times time plus half at squared. Okay, now we have all these quantities here we can calculate, and remember when you plug in the acceleration, it has to be a negative value. So we calculate this is the total displacement, 3.8 meters. That means 0.2 seconds later, the ball is 3.8 meters above where the motion started. So this is an example of a lacrosse ball, and here we are learning a few things. So first, how to reframe the position. Instead of knowing the position, we can find out the displacement. And secondly, if we find one equation that doesn't work, try a different one. Most people don't solve the equation just by reading it once and do it in one step. So it's a lot of trial and error. So if you are persistent, you're going to be able to solve the problems. In summary, we learned free fall motion. First, free fall motion is a special type of motion with a constant acceleration. This is when the motion is along the vertical direction, and also it's going straight up or down, and the acceleration is the gravitational acceleration. Motion description, So we still use displacement, velocity, acceleration to describe the motion. And there are 5 properties that characterize a free fall motion. Because it's free fall, 9.8 is usually not given explicitly, but you do want to recognize it's a free fall and add that into the set of known quantities that you have. And then we use a few examples to learn to solve different problems. So this is free fall motion.